Jupiter, the largest planet in our solar system, is a world of wonder. Its sheer size and presence dominate the celestial landscape, making it a subject of fascination for astronomers and space enthusiasts alike. It is a gas giant with swirling storms and colorful bands of clouds. These bands are made up of ammonia crystals, sulfur, and other elements, creating a mesmerizing tapestry of colors and patterns that dance across the planet's surface. But one of its most remarkable features is invisible to the naked eye, its magnetic field. This magnetic field is generated by the movement of metallic hydrogen within its core, a process that creates a powerful and extensive magnetic environment. This magnetic field is a giant stretching millions of kilometers into space. It forms a vast magnetosphere that extends far beyond the planet itself, influencing the space environment around it. It is so powerful that it dwarfs all other planetary magnetic fields in our solar system. In fact, Jupiter's magnetic field is about 20,000 times stronger than Earth's, making it a dominant force in the solar system. Jupiter's magnetic field is a fascinating and complex phenomenon. It is not just a simple dipole like Earth's, but has a more intricate structure with multiple poles and varying intensities. Understanding it helps us learn more about the planet itself. Scientists study the magnetic field to gain insights into Jupiter's internal structure, its atmospheric dynamics, and the interactions between the planet and its moons. It also provides insights into the formation and evolution of planetary systems. By studying Jupiter's magnetic field, researchers can draw parallels to other planetary bodies and their magnetic properties, shedding light on the processes that shape our universe. In this essay, we will delve into the intriguing world of Jupiter's magnetic field, exploring its properties, its effects, and its significance for our understanding of the universe. We will uncover the mysteries of this magnetic giant and appreciate the role it plays in the cosmic dance of our solar system. A magnetic field is an invisible force field that surrounds a magnet. This field is not something we can see with our eyes, but its presence is undeniable. It influences the space around the magnet, creating an area where magnetic forces can be felt. It exerts a force on other magnets and moving electric charges. This force can either attract or repel depending on the orientation of the magnets. When electric charges move through this field, they experience a force that can change their direction and speed. We can visualize a magnetic field as lines of force that emanate from the north pole of a magnet and curve around to the south pole. These lines are a helpful way to understand the direction and strength of the magnetic force. The closer the lines are to each other, the stronger the magnetic field in that region. The strength of a magnetic field is measured in units called Gauss or Tesla. These units help scientists quantify the intensity of the magnetic field, allowing for precise measurements and comparisons. Instruments like magnetometers are used to detect and measure these fields with great accuracy. On Earth, we experience the effects of our planet's magnetic field every day. This field extends from the Earth's interior out into space, creating a protective shield around our planet. It plays a crucial role in many natural phenomena, such as the beautiful auroras seen near the poles. It protects us from harmful radiation from the sun. The Earth's magnetic field deflects charged particles from the solar wind, preventing them from reaching the surface and causing damage to living organisms and electronic systems. It also allows us to use compasses for navigation. The magnetic field causes the needle of a compass to align with the magnetic north, providing a reliable way to find direction. This has been an essential tool for explorers and travelers for centuries. Magnetic fields are generated by the movement of electrically charged objects. When these charges move, they create a magnetic field around them. This principle is fundamental in many technologies, including electric motors and generators. In the case of Earth, the magnetic field is generated by the movement of molten iron in its core. This process, known as the geodynamo, involves the convection of molten iron and nickel, which generates electric currents and, consequently, a magnetic field. This field is vital for maintaining the conditions necessary for life on our planet. Jupiter's magnetic field is much stronger than Earth's. This immense difference is not just a matter of scale, but also of complexity and dynamics. It is about 20,000 times stronger, in fact. This staggering figure highlights the sheer power of Jupiter's magnetic influence in our solar system. This vast difference in strength is due to several factors. Firstly, Jupiter is much larger than Earth. Its massive size plays a crucial role in the generation of its magnetic field. This means it has a larger volume of material that can contribute to its magnetic field. The planet's interior is composed of layers that are rich in conductive materials, which are essential for magnetic field generation. Secondly, Jupiter rotates much faster than Earth. This rapid rotation is a key factor in the dynamo effect that generates its magnetic field. It completes one rotation in less than 10 hours. This swift rotation speeds up the movement of conductive materials within its interior. This rapid rotation generates strong electrical currents within its metallic hydrogen layer. These currents are crucial for the creation of Jupiter's magnetic field. These currents, in turn, create a powerful magnetic field. The interaction of these currents with the planet's rotation amplifies the magnetic field to extraordinary levels. The structure of Jupiter's magnetic field is also different from Earth's. While Earth's magnetic field is relatively straightforward, Jupiter's is far more intricate. Earth's magnetic field is relatively simple, resembling that of a bar magnet. This simplicity is due to the uniformity of the materials and the slower rotation of the planet. Jupiter's magnetic field, on the other hand, is much more complex. It is influenced by the planet's rapid rotation and the diverse materials within its interior. It is tilted at an angle to its axis of rotation. This tilt adds another layer of complexity to the magnetic field's structure and behavior. It also has a shape that is constantly changing due to the interaction of its magnetic field with the solar wind. This interaction causes the magnetic field to stretch and compress, creating a dynamic and ever-changing magnetic environment around Jupiter. The powerful magnetic field of Jupiter also leads to spectacular auroras at its poles, much like Earth's northern and southern lights, but on a much grander scale. Understanding Jupiter's magnetic field is not just an academic exercise. It provides insights into the planet's interior structure, its atmospheric dynamics, and even the behavior of its moons. For instance, the volcanic activity on Io, one of Jupiter's moons, is influenced by the planet's magnetic field. The interaction between Io and Jupiter's magnetic field generates intense electrical currents that contribute to Io's volcanic eruptions. Jupiter's magnetosphere, the region dominated by its magnetic field, extends millions of kilometers into space, far beyond the planet itself. This vast magnetosphere acts as a shield, protecting Jupiter and its moons from the solar wind. In the grand scheme of the solar system, Jupiter's magnetic field plays a crucial role in shaping the space environment around it. It is a testament to the planet's immense power and influence, a tale of two magnets indeed. While Earth's magnetic field is vital for life on our planet, Jupiter's magnetic field is a colossal force that commands respect and awe in the vast expanse of our solar system. The region of space around a planet that is dominated by its magnetic field is called its magnetosphere. Jupiter's magnetosphere is the largest structure in the solar system. It extends millions of kilometers into space, far beyond the orbit of Saturn. This giant magnetosphere acts as a shield, deflecting most of the charged particles from the Sun. These particles, known as the solar wind, would otherwise strip away Jupiter's atmosphere over time. The interaction between Jupiter's magnetic field and the solar wind creates stunning auroras at its poles, similar to the northern lights on Earth. Just like Earth, Jupiter has auroras at its north and south poles. They are caused by the interaction of charged particles from the solar wind with Jupiter's magnetic field. When these particles collide with atoms in Jupiter's upper atmosphere, They excite the atoms. This causes them to emit light. Jupiter's auroras are much more powerful and energetic than Earth's. They can even be seen in ultraviolet and X-ray wavelengths. The auroras on Jupiter are not only a beautiful spectacle, they also provide scientists with valuable information about the dynamics of Jupiter's magnetic field and its interaction with the solar wind. The Great Red Spot is a massive storm in Jupiter's atmosphere. It has been raging for centuries. While the exact nature of the Great Red Spot is still a subject of debate, scientists believe that Jupiter's magnetic field may play a role in its persistence. The magnetic field lines around the Great Red Spot are thought to be twisted and tangled. This creates a sort of magnetic cage. This cage may help to confine the storm and prevent it from dissipating. Further study of the Great Red Spot and its interaction with Jupiter's magnetic field will help us to better understand the dynamics of planetary atmospheres. In 2016, NASA's Juno spacecraft arrived at Jupiter. It began a mission to study the gas giant in unprecedented detail. One of Juno's primary objectives is to map Jupiter's magnetic field and study its structure. Juno is equipped with a suite of instruments designed to measure the strength and direction of Jupiter's magnetic field. The data collected by Juno is providing scientists with an unprecedented view of Jupiter's magnetic field. It is revealing the complex processes that generate and shape it. The Juno mission is expected to continue for several more years, providing even more data and insights. Jupiter is a natural source of radio waves. These radio waves are generated by the interaction of charged particles with Jupiter's magnetic field. Some of these radio waves have frequencies that can be detected by radio telescopes on Earth. By studying Jupiter's radio emissions, scientists can learn about the properties of its magnetic field and the processes that generate them. These radio emissions also provide clues about the structure and dynamics of Jupiter's magnetosphere. Section 9. Jupiter, a protector of planets. Jupiter's massive magnetic field plays a crucial role in protecting the inner solar system from harmful cosmic rays. These high-energy particles from outside our solar system can be dangerous to life. Jupiter's magnetic field acts as a giant shield, deflecting many of these cosmic rays away from Earth. Some scientists believe that Jupiter's presence in our solar system was essential for the development of life on Earth. Without Jupiter's protective magnetic field, Earth might have been bombarded by much higher levels of radiation. This could have made it much more difficult for life to evolve. Section 10. Magnetic fields and the search for life. The study of magnetic fields is also important in the search for life beyond Earth. Scientists believe that a planet's magnetic field is essential for habitability. It protects the planet's atmosphere from being stripped away by the solar wind. It also shields the surface from harmful radiation. Future telescopes and space missions will be able to detect and study the magnetic fields of exoplanets. This will help us to identify planets that might be capable of supporting life. Section 11 of Future Exploration, Unraveling the Mysteries. Despite all that we have learned about Jupiter's magnetic field, many mysteries remain. Future missions to Jupiter will continue to explore the complexities of this giant magnetic field. They will use even more advanced instruments to study its structure, dynamics, and interaction with the solar wind. These missions will also investigate the role of Jupiter's magnetic field in the formation and evolution of its moons. They may even search for evidence of subsurface oceans on moons like Europa, which are thought to be potential habitats for extraterrestrial life. Section 12. Jupiter's magnetism, a window to the universe. The study of Jupiter's magnetic field is not only important for understanding our own solar system, it also provides insights into the processes that govern the universe as a whole. Magnetic fields are ubiquitous in the cosmos, playing a role in the formation of stars, galaxies, and even black holes. By studying Jupiter's magnetic field, we can learn about the fundamental laws of physics that govern these magnetic fields throughout the universe. This knowledge will help us to unravel the mysteries of the cosmos and our place within it.